Hello, Scott Knight here speaking. All of us in our group played a part in calibrating and setting up the traffic light scenarios, but we each had a special project, and the one I worked on was the tachometer installation. The tachometer is a 4-pin board. It has a AO and a DO, a ground and a VCC pin. I believe AO stands for analog out, and I'll talk more about that later. The physical device that attaches to the motor shaft has 20 notches in it for light to pass through, so 20 light pulses is one revolution. And this is the tachometer, obviously, before it's installed. And I removed the top section of the car, and I don't show the mark here, but I marked out where I wanted to, cut the car prior to cutting it because, well, I guess we have 4 shots, but I wanted it to work on the first shot, and it did. So to cut the car, I actually used a drill bit that I heated up in my stove till it was flaming red hot, and then I drug it across. Well, I inserted it and then drug it across the mark that I made. And this worked. To make it look nicer, though, I took a lot more time. So I have a small file set, and I used the small file set to kind of carve out neatly where the slot for the tachometer rotor was to go. And I don't really have a lot of good pictures to document this. I kind of got before and after, but you'll see in the next slide how it turned out. After I cut the slot for the rotor attachment, I made a bigger notch. I marked out where I wanted to here, and the same. Actually, I didn't use the drill bit for this because I already had cut into the plastic, but I used the file to, make a nice rectangle here for the board sensor to stick up through. It did take a fair amount of time, probably a couple hours to do this and all. But it turned out pretty good. No cracks, nothing like that, nothing catastrophic. Right here, I had to use the drill bit again it was a very small drill bit, like maybe 1/64th size. And I ended up throwing it away because I wouldn't trust it now, but that's how I started it, and I had another file that was a circular file, very small file set. I don't have it on hand, but yeah, and I had a screw and a lock nut, not a lock nut, but a regular nut that I was able to secure it to the car. And I don't have a picture showing this, but the wire just went under the car through here and up and over, and I had to make a little bit of an extension to make it to reach, but there you have it. That's the tachometer install. Oh, and one more thing. I did some troubleshooting initially to make sure it worked. I hooked up a digital multimeter, and I spun the wheel with the car on, and I had the multimeter attached to the AO and the ground, and I was getting a voltage signal output. So it made me confident that I had installed the sensor up far enough to allow the light to pass through the holes in the wheel attachment. Just trying to stop this video.
Hi, this is Jason. So Scott's already mentioned that in our group we all work together on calibrating, setting up, and testing the car. And he's also talked about installing the tachometer. So now I will go over the code for the tachometer. I've created a simple flowchart. So starting at the top, we have the defined variables. So we use digital pin 2 as the input pin for the tachometer. For the pulses, which counts the number of notches, I used volatile byte because in Arduino, when you have a variable that's value changes from something beyond its section in the code where it appears, so like in an interrupt service routine, then you need to use volatile to define the variable. So, and next I have, I use a long variable for keeping track of the time, and finally I have pulses per turn, which is 20 because there are 20 notches in the tachometer. So at the bottom left, setup function, I set pulses, RPM, and the time tracker to 0, and then I set the encoder pin. I define it to behave as an input pin, and then I also set the interrupt to trigger whenever there is a falling edge. And this would happen whenever a notch passes through the sensor slot on the tachometer, because look here, data sheet says here, when something passes between the slots, it creates a digital pulse on the pin, so this goes from low to high. So on the other hand, when you have a notch passing through, the voltage on the DO pin would go from high to low. That's why I have this interrupt triggering on falling when the pin goes from high to low. And here's the interrupt function. Just basically just incrementing pulses by 1 whenever a notch passes. And on the right here is a loop function. I pause every second to calculate the RPM and print out the RPM to the serial port using millis and the current time, which starts off at 0. And after I do that, I set pulses back to 0, and I set the current time to equal millis, and then I resume interrupt processing, because you don't want to be, counting pulses while you're already calculating a current, RPM value. So there's the RPM code. Yeah.
So here we have a flowchart that depicts the logic that the robotic car will follow. It will use the Pixie Cam as a sensor to detect the light color of the stoplight. After detecting a color, the car will calculate the distance from the stoplight. If green is detected, the car motors will receive a forward voltage despite any distance calculation. If yellow is detected and distance is greater than 15 inches, the car will maintain its speed. If yellow is detected and the distance is between 15 inches and 10 inches, the car will slow to a stop. This distance allows the car to stop between 6 and 2 inches of the stoplight. If the light color detected is yellow and the car is less than 10 inches away, the car will maintain speed. If red is detected and the distance is greater than 15 inches, the car will maintain speed. If red is detected and the distance is calculated to be less than 15 inches, the car will slow to a stop. this logic is looped back continuously. So the PixieCam or the robotic car will constantly be checking the stoplight color. Here we have the Pixie monitor view as well as the serial monitor. This is the green light demo. So on the serial monitor, we have color being printed, color detected, distance calculated, RPM from the tachometer, translated to speed, and also time until stoplight. This calculation actually is never used in the code, really. So following the logic, the car will just run through the green light. So now we have the yellow light. This is going to be the slow to stop demo. So you can see the robotic car stops within acceptable range. Here we have the yellow light run through. So the car is going to start at a distance where there's not enough time to stop. So it will just be running through the yellow light. And here we have the red light demo.
Green light demo recording. Hello, Scott Knight here speaking.